Okay, so in this problem we have a system that we're going to solve, and we would call these nonlinear systems. So systems are solved by looking at their points of intersection. So if I look at these few shapes that we have here, I could look to determine how many different points of intersection they have. So I look at this first one. We're going to say that these guys hit at exactly one point. And there's some sort of tangent line that goes through there. But this is one solution. So I look to see where they cross. We have a line and an ellipse. There is no solution. There's no crossing, so there is no solution. Okay? And then I go to this third one right here, and I look at two ellipses that are crossing, and I have 4 different points of intersection, so there are 4 solutions. And so by a graph, I can look and I can see how many times it crosses, and that's how many solutions there are. And there's a bunch of different types of shapes that could crisscross when we're dealing with conics, but we're going to solve these algebraically, but basically we're looking to see how many times they cross. When are they equal to each other? And it's as simple as when we were doing just lines and using substitution and elimination. Our first example, first thing we're going to do is we're going to identify the type of conics. We're going to get some practice with that, and then we're going to solve the system. And we're not going to use graphing. We're going to use either substitution or elimination. Okay? So now, as I go through this one, let's name the shapes. Well, this first one is a line. Okay, we should know it's a line. Well, and this guy has just got the x squared and the y squared. It's a 1 and a 1. So A is equal to C. So this guy right here is a circle. And I should already know, okay, I got a circle and a line. Probably the most points that I'm going to see cross are 2, right? Because if a line goes through a circle, right, it could look something like that. Could be no points, could be 1 point. Really, the most I'm going to cross is 2. So if I get something more than just 2 points, then I know I've done something wrong. So let me go ahead and shrink this real quick, and we can kind of work this problem underneath. Okay? So I'm going to rewrite everything. So I got y is equal to 3x, and x squared is equal to, not equal to, plus y squared is equal to 16. So I'm going to go ahead and we could use elimination or substitution. I'm going to use substitution. It's already set up for y equal to 3x. So I'm going to go ahead and solve by substitution. And so I'm going to plug that 3x in for y. And be careful here. I don't know why I keep on writing the equal sign. When I plug in that 3x, it's that whole thing squared. So I put in parentheses. Don't mess that up. Okay? So now I'm going to go ahead and get x squared plus 9x squared is equal to 16, and I'm going to get this set up and simplify. So I got 10x squared is equal to 16. So this is potentially kind of messy. So I'm going to divide it out, and I get x squared is equal to, I'm going to keep it as 16 because I know it can reduce, but I know the square root of 16 is 4, so I know that radical at the top is going to cancel out. So I see that, and so when I take the square root, I'm just going to go ahead and don't forget the plus or minus. I know I have the square root of 16 over the square root of 10, which is going to reduce to plus or minus 4 over root 10. Can't have radicals in the denominator, so I'm going to rationalize, and I get my x value equal to plus or minus 4 root 10 over 10. I can reduce, which is 2 root 10 over 5. That's a 10, not an 18. Okay? Okay, so now how do I find my y values? Well, I'm going to go ahead and shrink this and move it. And I'm going to go ahead and I know that x was equal to plus or minus 2 root 10 over 5. So to find my two results, I plug the positive one in to find y, and I get y is equal to 6 root 10 over 5. Or I can plug in the negative one. So really, it's just going to make this guy negative. So I have a positive and a negative version. So, or I'm going to get a negative 6 root 10 over 5. So how do I put these guys together? So I'm going to have 2 points here. I'm going to have the 2 root 10 over 5 and 6 root 10 over 5. That was one point of intersection. So this is one of them. The second one was the negatives. And those are my 2 points of intersection. So we're solving systems that are more complex. We get, because of those squares, we get some radicals and some funky numbers. So you just got to be careful with your algebra and take your steps and make sure you rationalize right. And that's one of the biggest errors that I see. Okay? So please be careful with these.